Oral history recording of William L. Larry Lennon of 1533 Smoke Drift Lane, Lansing, Michigan 48917. Larry's phone number is area code 517-323-2457. The recording was made by Jim Walkinshaw at the Oldsmobile History Center on February 27, 1992. This is tape number 1 of 3 tapes. See, Larry, if you just start with your name and your address and your phone number, please.
Okay, my Oldsmobile name is William L. Lennon, but I always went by the name of Larry Lennon. Current address is 1533 Smoke Drift Lane, Lansing, Michigan. Phone number 323-2457.
What's your zip over there, Larry?
Oh, 48917.
Okay.
All right.
And then if you just kind of take us back to when you started and what was going on and
Okay.
where you were.
I hired into what we called the Methods Engineering Department in Building 40 in June of 1952. And I was assigned to the job improvement activity. I think at that time the Methods Engineering Department had approximately 11 people, divided into about 3 groups. We had the job improvement, we had the defense group that was primarily concerned, I believe, with starting the jet engine project at Plant 3. We had an assembly group, and there was one man, I think, assigned to so-called advanced development. The department was headed by Ed Ditto, and Bob Russell was the director, department director. As part of the job improvement group, I worked all over the plant and was assigned various areas to review and so on to come up with improvements using accepted method techniques.
Which were what in those days?
Okay, now I knew we were going to get into that, and I'm a little hazy, although I made some notes here.
Okay.
That some of the things we could do in those days because of cooperation really of management and I think even the union, we could take photographs and moving pictures of the jobs.
Okay.
And the equipment we had at that time was pretty antiquated. We had an old gun camera that was used, I don't know what fighter plane, but it came out of the wing of a fighter plane, what they used to record the shots anytime the guns fired. And that was our camera in the department. With this camera, we could go out and photograph or film an operation. And most of the operations at that time that we were concerned about were operations usually of less than 1 minute, because the assembly lines and most everything were paced at least 60 an hour, although I think the assembly line actually was running at 80 or 90 an hour at that time. Mm-hmm. So we could film these operations, and then we would come back and by counting the frames and so on, analyze the operations. And primarily we were looking for, in modern times they call it ergonomics. We weren't so sophisticated. We were looking to see what can we do to make the operator's job easier. Is he walking too far? Is the stock convenient? And one of the classics is always, is he using one hand as a hopper? Okay. Jim probably remembers that. So we would analyze the films, and we actually had a small methods lab, Jim. It was what, 16B out in, or 16C out in a area there past the body.
Stuck out in the.
Right, you had to walk through the body storage area.
It was actually in over building 25.
Yeah. And in there we had hoppers, so on, and we could hook up air tools and so on. And we would try and duplicate the job as it existed and then improve it and so on. And surprising enough, we did save quite a little money. And at that time, you were after tenths of a cent. If you could save a tenth of a cent a car, you were a hero. And later on then, we obtained actually what we called a memo motion camera. We bought a new camera. And with this camera, it took 1 frame a second.
Oh.
And I remember one particular job that I worked on with that camera. It could, I think, run approximately 8 hours on a roll of film. So we would use this for very long, erratic interval type jobs. And I know one of them that I worked on specifically is in the old Meeker plating system. They transferred the bumpers or bars, as we call them, from copper to nickel. Is that right? Or was it nickel to chrome?
Oh, it could be either. Yeah.
Can't remember which one. In other words, the bar could stay in the same rack through either copper or nickel and had to transfer it chrome, or it had to transfer from copper to the nickel chrome, different rack. And there were, I believe, 4 men doing this. And every time I would just visually look at the job, I could only see 3 men actually working at that time. So reluctantly, management gave us permission to film that job for, I think, 8 hours. And so we went down and set the camera up, and actually, I don't think we were around most of the time. It was just sitting there.
On automatic.
Yeah, just running 1 frame a second. And then came back, got the film and analyzed it. And I found that at no time in any of the frames were 3 people working. And in fact, usually there were only 3 people in the area. And usually only really 2 people. 2 to 3 were actually working. So I took the film in and we made some short clips and loops of it and got the superintendent in, and he was a little amazed, a little upset. And I told him that he did not need 4 people, and this happened to be a 3-shift job, if I remember right at that time. He did not need that many people to transfer the bars. Well, he thought he was going to have a lot of problem with the union, and I don't remember all the ramifications, but I do recall in talking to the actual operators on the job, they all recognized that they really weren't working. So I think they agreed to take 1 man out, not 2 men, but they agreed to take 1 man a shift. So there were 3 men a day. So, and you'd think there'd be a little resentment, but as I recall talking to people, there really weren't, because some of the most boring jobs in the place are when you don't have to work. And if you can work at a more leisurely pace and so on, where they had actually been a little bit, I don't want to say apprehensive, so on, because they were having to hide all the time. There just was not work to do. So we used this camera, and it worked out quite well on, as I say, long interval jobs, and was quite accurate. But I know the last few years we were not permitted to photograph, use movies or anything.
Stopped, huh?
It got stopped. And one of the other things, and it was kind of interesting in that department, thinking back in the early years, I think twice a month the department had a meeting the last 2 hours on Fridays. And with 3 groups in the department, each group was responsible for every 3rd meeting. And to prepare for this meeting, you would have to go out then, maybe I think in the group I was in, there were only 3 of us at most. So one of us then would have to pick a job, make all the analysis, do all the graphing and so on, and take this then into our group meeting. And then it would be critiqued by the team.
The whole gang?
the whole gang.
Oh, yeah.
And of course, then it was always two groups against one.
Uh-huh.
And some of the names that kind of roll off that were part of this activity were Bob Truxell, Mike Harper, who was, I think, chairman of the board of Agricon,
Mm-hmm.
and Bill Slachta was part of it. We had some Bob Mooney, some rather,
These were all engineer types.
yeah, at that time. Yeah, I think Truxell was considered a leader of one of the groups,
Okay.
and Harper was my leader.
Okay.
Ken Knight was in there at that time. So we had some rather interesting discussions. In fact, several times I thought we were going to have a brawl over the right way to do the job. But it was, and we learned from it. And on occasion, then we would, for a particular meeting, we may have a superintendent of that area come up with the assistant soup, if we even had assistant soups then. But it was interesting, and I think we learned a lot. The thing I recall about those early days was I worked all over the plant. There wasn't any area that I probably didn't feel at least comfortable going into.
Do you remember how they picked what area you were going to go work on, or was it just kind of a
well, the superintendents quite often had pet projects that they wanted some help in this area. I know one of the areas that I spent quite a bit of time on was the engine block line, the V8 block line, trying to figure out why they weren't getting production. You had to analyze each operation and make overall flow charts and where were the bottlenecks and so on and what could be done. And in some of these jobs, we might have somebody from each of the groups. We weren't that sacred. We didn't have that much manpower because I think on the block line, we had to analyze that all three shifts. So maybe two of us would each work 10, 11 hours a day. And what you would do there is maybe you kept counting the float ahead of each operation. And when that float went to zero, you had to figure out why it was a zero. And because then you got a snowballing effect of why they weren't getting the blocks off the end of the line.
Didn't the regular process guys do any of that kind of stuff?
No.
The block process?
No, they really didn't. It seemed like most of your machining engineers at that time had come up through the tool room. Very, very good skills from a machining tooling standpoint, but probably not quite as strong as they could have been in the analysis of the man-machine relationships. So that was one area I know I worked in. I worked in the 3.5 rocket activity for a while. Seemed like they had some bottlenecks in the painting operations or something, and there were several operations in there. I'm hazy now that required brazing or something.
The fins.
Fins, yeah. That and well, I worked in the 90 millimeter cannon for a while when they set that up. It was a 105 millimeter, I guess. Originally they built the 90, and then several years later they built the 105. And one of the other areas that kind of sticks in my mind was when Hydromatic had their fire. I was quite new in there. I think that was in the
53.
Fall or early spring of 53.
Yeah, it was in 53.
Because I know it's a 53 model.
Right.
And Oldsmobile at that time then undertook to make certain components.
Okay.
And one of the areas was the transmission case, where they apparently GM had a bunch of old machines stored, government-owned machines from the war that they were required to store. And they brought all these mills out and so on, and I was part of that group. But
where did we do all that?
well, we did that in the engine plant.
Down in the engine plant?
Yeah, down in the engine plant. I'm a little bit hazy just where. I think back where the cylinder head assembly or something ended up.
And we were machining the case, huh?
We were machining the case. We got the castings in, and then we would machine the case and ship it to somebody else. But the activity I worked on most was a Taurus cover. And we had a Taurus cover that we stamped and were machining, and the vane, I can't remember what the vanes that went in. I guess that was the Taurus, the cover and the Taurus, and then the Taurus had a whole series of vanes. And I remember Charlie Cates was the primarily engineer, but Charlie and I worked very close together. Usually we always had to have tried to have two people that were working together so they knew what was going on. And Charlie and I tried to develop an automatic vane loader to put these little vanes in, and that was quite interesting. Charlie was very good at that.
We had done much of that kind of thing?
No, we had, well, not the automatic assembly, and even the Tauruses, and I don't know, I suppose Hydromatic were hand assembled.
All those little...
Yeah, so Charlie and I decided we could make an automatic one. Well, we frogged around about 3 or 4 months and got a vane loader, but it was really never completely perfected at the time. The jobs were pulled out of Oldsmobile. Hydromatic had got back in business. But the one that I worked on quite a bit, was quite interesting, was, so I recall the inside of the Taurus cover was ground at a very precise dimension. And we didn't have any grinders was our main problem, so we figured it had to be a better way. So some way either somebody suggested it or I found a bearingizer. And I can't really give a very good description of it. Bearingizer is a rotating tool that has a series of hardened rollers around the periphery that cam out, and as the tool rotates, it cams these rollers out to a very precise dimension, and it gives you a very accurate dimension. So under pressure of the cams, and you can get these built. And we were using old drill presses. We got some old drill presses to try and bearingize the covers, but again, as I think back on this, you had to have a good cover to start with, and you were trying to take out the tool mark, because the bearingizer really was a very precise instrument. But we did actually get it to a point where it was feasible. I'm not sure it ever really got quite perfected. Again, we gave up on all those jobs and turned all of our information over to Hydromatic and so on. Now,
this is when they must have got their other plant functioning.
Right. Yeah, they were slowly pulling things back. And how many of those we actually made and put in production, I don't remember. But I think it was late in the spring or early summer. I remember it was warm weather that they pulled that stuff back. And then we went back into our normal mode of operation then. So that's some of the kind of earlier things that I remember as part of the job improvement group, and I think I was on that about 2 years. It turned out to be to a point I was ready to quit. I was so bored.
Really?
Oh yeah. Well, you had no responsibility, and you were always in somebody else's area, a production engineer, a sheet metal engineer, trying to improve their jobs. And some of them were maybe not as cooperative as they should be, but because they felt those were their areas. And I think one period of about 6 months' time, my sole contribution, I had moved 2 operators' control panels several feet to give them a little better access, and hung some air wrenches on balancers for them. They use a lot of air wrenches in those times to tighten and untighten the chucking fixtures, on machinery. So we got air wrenches where maybe you'd been using a hand wrench and hung it on it, but it was very, very boring. So I asked and eventually received some direct assignments, and my assignment at that time was to take the assembly responsibilities and what we called the old axle plant in Building 21.
Okay. This is
And
where we assembled the rear axle?
the rear axle, the front axles, and also the plating system was
Okay.
in Building 78 at
All
the
right.
west end. So the one methods engineer, we didn't call them industrial engineers at that time, had responsible for that building plus job improvement in all the machining areas.
Oh, wow.
So I felt a little better then. There were some things I could get my teeth into. And one of the projects that probably has kind of fallen by wayside was very interesting. I think it was in 1955. We were having a lot of differential noise. So I was given a challenge to try and analyze differential noise. How do we know if a car is going to be noisy in the differential? And the cars at that time, of course, all rear drives, had what we called the banjo type axle housing, which was a large stamping of which the differential was bolted into the banjo. Whereas in later years, I think 1957, 58, they used what they called the Salisbury type, which was a much larger casting that the tubes, axle shaft tubes, actually pressed in. But before that, we had this banjo. So I finally got a project approved with more money than I'd ever seen before. I know it was well over $100,000, which was a lot of money back then, to build a building, an enclosure, and buy a dynamometer test stand.
Oh, okay.
That we located in the center of Building 21. And with this dynamometer, we could load the differential just as if it was in the car. We could drive it through the pinion, or we could put it in coast, as like when you're coasting down a hill. We could drive through the axle shafts and let the pinion take the load. So these are rather large motors and so on, driving these units. And then for picking up noise, we had analyzed the frequencies as best we could of where noise occurs. And as I recall, most differentials, 25 to 30 miles an hour, and the harmonic, which would have been probably 55 to 58. So those were the speeds we concentrated on. And then we had a series of filters that we tried to filter out, and we could replace these filters. We had a lot of contact with GM Tech Center on this. And they kept analyzing filters so we could block out certain...
These are noise filters.
Noise filters, okay, and only pick up the filters that we wanted, or the frequencies we wanted. And the operator in there had meters that he would analyze each differential. And if it fell within a noise range, we rejected it. I think Pontiac at that time was our source.
Gearboxes.
And then as part of our program, we would also take all the noisy differentials or control differentials out of cars. That the test, every car was test driven, I think, at that time, or at least on the test roll. And if they found a noisy differential, standard practice was to change it.
They changed the whole rear axle, or just the differential?
Just the differential.
Okay.
And which was again about probably in the line as good as they were, half, 3/4 an hour. You had to pull your shafts, drop your prop shafts, and a lot of fooling around to change it. And then we'd take those differentials back into our noise booth and rerun them and see if we could correlate. Well, our correlation was never, I'm going to say, better than 75%. But we did learn a lot of interesting things, that certain models of cars were noisier than, as I recall, station wagons were the noisiest car. So we earmarked, whenever we tested differentials, if we found what we thought was a very quiet one, we would earmark that for a station wagon if we could. And we ran a lot of correlation, and I think until the axle plant moved to over to plant 3 in 57, we correlated differentials up to that time, but they went to the Salisbury type. But again, it showed improvement, and I think one of the things that fell out was that Pontiac also put in at that time then a series of these booths based on the work we had done. So they were qualifying them at that point, and differential noise definitely got considerably better.
So that was a thing that nobody really did much about previous to that point in time.
Well, I don't know what triggered it, Jim, whether as they redesigned the cars, put more horsepower in them. Of course, people were becoming more aware of noise, I think, in cars.
Cars were getting quieter.
Getting quieter. And this whine, it is objective. In fact, front-wheel drive cars today, I've noticed a few of them, you can definitely hear what I would call differential noise.
Yeah.
But it was a thing that was being picked up in the field, and dealers were having to change differentials and so on. And it was just an area that...
It was kind of the problem of the day, so to speak.
Yeah, it was not a safety problem, but it was a quality problem, and we did work on it. In 57, then the axle plant moved to plant 3. We also changed to, I think that's when the ball joints came in. Before that, we had always used pins and bushings, in knuckle, steering knuckle support, kingpin, and caster and camber was adjusted with a pin and a bushing and so on, with a 57, which I think was a completely new design car. And I think the Salisbury axle came in at that time, as well as a completely new front suspension. So the axle plant moved to plant 3, and again I moved with the processing. But the engineer normally assigned to plant 3, no, I guess they decided at that time, since we had a methods engineer in plant 3 that was not part of the defense program. I think the jet engine was out of there by then.
Yeah,
it had phased out, so we were taking over space that the jet engine had occupied, and they were putting in the new plating plant and so on, all kind of simultaneously. But the engineer was also assigned to the forge plant. The forge plant, I think prior to that, operated pretty much as an independent operation, but it was being slowly pulled in under the main plant activity, much to their chagrin, because I was assigned the forge plant industrial engineering or methods engineering responsibilities too. Yes, they had a full-time person that had left, and Mooney had been over there, but Hoffman had been over there. But I think at least as far as the methods, they wanted more of a homogeneous activity with the main plant, which it hadn't been in the past. It had been standalone. In fact, the engineers actually assigned over there reported right to the plant manager.
Well, had they?
Yeah. And when I was assigned over there, I did not report to the plant manager. I was part of his team or staff, I guess, as they would now call it. But I reported back to Bob Russell.
Back and forth.
Yeah,
Right.
through my supervisor, I think was Bud Borkman at that time. But shortly after that, we started to put the F-85 front and rear suspension in the forge plant. Yeah, okay, Jim shot. And we probably started to work on that in about 1959, because I think it came out as a 61 model. Yeah. And it was a very hush-hush project originally. I know we did an awful lot of the processing from plant 3, even for the main plant.
Oh, did you?
Yeah.
Oh,
All the original processing was done at plant 3.
interesting. Like for the car assembly too?
Mm-hmm.
Oh.
Yeah. And I think, as I think back now, I can't believe it, but Larry Kerr and myself, and I believe Jim Leonard, who was writing his 5th year at that time, processed the whole original F-85. the whole car. Now, it seems hard to believe, but I know later on other people were brought in. Ken May was brought in when we got down to the nitty gritty. This was under Ken Knight. I want to say we had a fourth person. Maybe Jim Leonard had by this time completed his 5th year, but I don't believe there were more than 4 of us. And then I pretty much had complete responsibility for the front and rear suspension assembly, which was done in the forge plant. And the F-85, or X-100 is a lot of documentation, we'll call it, had some very interesting features. The front suspension was actually built on a cross member.
Okay.
Built on a cross member that had 3 mounting points, 2, one near each wheel and a center point in front. And then in these mounting points was a big rubber mount called an isolation mount. And when they actually assembled this to the car, the engine sat right on it. The complete front suspension was there, and that just moved, raised right up into the bottom of the car and mounted on those 3 points.
Stuffed it.
Yeah, you just stuffed it up. And the rear suspension was, well, again, it was a body frame integral, the first one we had ever built. So the rear suspension was a little bit the same way. It was built up with again a Salisbury type axle, several control arms, and raised up, although we had to compress the springs and so on to do it. And we had what we called the marriage. I actually did not probably work on that aspect too much because the workload at the forge plant just on the complete front suspension was quite a bit. But some of the interesting things I recall that we did on this, developed a system that we actually forced the front suspension. Now it had the control arm, steering knuckle. I'm hazy on whether or not the steering linkage was on it at that time. I do not think it was at this particular. But I had a fixture design that we located on these 3 isolation mounts, and we forced the suspension into the correct position by compressing the springs, and then we stuffed the shims to set the caster and camber.
Wow, not even on the car.
No, so in theory, the whole front, and I think probably, I'm hazy now, but at that time while we had it in that position, I believe we might have put the steering linkage on and set the toe in. I wouldn't swear to it. And the brakes, after that, then we located on the steering knuckles. We then put the brakes on, set the brakes, hubs and drums and everything. So in essence, the front suspension was all ready. And then when it went to the main plant, they set the engine on it. And as I mentioned, raised the engine up in. So there wasn't a tremendous chassis assembly on that car because so much was done off the line. So the F-85 line there in building 16A, B, and C, I guess it was comparatively short assembly line. But in the Ford's plant, we also did the rear axle, and at that time, I think we had gotten into, had we gotten into gear cutting?
No, I don't think so, yeah.
Did we buy the Salisbury? I guess we bought the Salisburys, but we did make the tubes.
Okay.
Hot up, set the tubes, machine them, press the tubes in the rear axle and everything. So again, the rear axle went out with brakes and everything on it, ready to go into the car. The control arms, I recall, I think were processed at plant 3, because I remember I had the job of putting the, I think the bushings in.
These big rubber bushings.
I'm not so sure that wasn't done on building 78, but maybe that was on the BC car. It doesn't matter. But anyway, that the F-85 then it gave us 2 complete car lines, and of course that became the Cutlass Supreme, right, as we know it today. So I remained on in those areas until I think about 19 '64.
Now, did you actually have an office in there at both plants?
Yeah, I had an office in both plants, and
Back as far.
yeah, the office in Plant 3 was right across from Superintendent's office. So Bernice Hake did my typing and stuff over there for me, and then I had a nicer office at Plant 3, Ford's plant, once they rebuilt them. And I think well, he was no longer a plant manager at that time. He was now called, I think, a superintendent of the Forge plant. And that was Elmer Corbin, and his secretary, can't remember her name.
Is that Ruth?
Yeah, Ruth. Ruth, yeah. Ruth did my typing for there. It was an interesting experience working between the two plants because, of course, they had different unions, different repair people, and so on. Some of the assembly equipment for that operation had been built at Plant 3 in the tool room there.
Oh, that?
Yeah.
Okay.
Although most of it came from outside.
All right.
But a few of the fixtures had been built there, but the Plant 3 people could not go over for any maintenance because of the Ford's plant having a different union. And of course, the Ford's plant people operated completely different. I can recall having several discussions with the plant engineer there about who controlled the drawings and how they were to be kept up to date and so on, because they were not used to operating in that vein, although
they didn't do that,
they didn't do that.
Yeah.
So it took quite a struggle to get, especially wiring diagrams and so on, kept up to date, because the electricians had a habit of just going in and making changes and maybe marking a print and leaving it in the panel, and never telling you that they had made this change. Not that there was a necessary problem with the change, but just that your tracings were not up to date.
So if anybody in the future needed it,
right, you'd run them off a copy off the tracing. So the tracings were kept at Plant 3 because the tool design section was there. I did not use the die design group at Plant 3. There was a very distinct dividing line between the tool design at Plant 3 and the die design. Die design at Ford's plant was salary, for one thing.
Oh, yeah. Okay.
And tool design at Plant 3 was hourly. Although the designs had all been done on the outside, and the machines, most of them had been built on the outside, it was still Plant 3's responsibility to keep the changes up to date and so on.
Can you contrast the organizational approaches at the two plants? Is there something there?
Well, the Ford's plant for years had operated, as I say, as an independent plant. And something that always sticks in my mind was the main plant, as we call it, was always over to Olds. For years, anybody in the Ford's plant called it over to Olds. I was never accepted as a member of the Ford's plant team by the people. I was always accepted as being from Olds. Whereas they did have their own people. Basically, all their plant engineering people were Ford's plant people. Their manufacturing people, most of them were had come up through the Ford's plant operation, being a different type of activity, and even the lab people. I think about the time I went over there, the Ford's plant lab was brought under the main plant lab people. So they were going through the same transition, but the people that, as I recall, that were in the lab had come up through the forge. So again, there was a problem, a little in communications and integration and so on. I recall one of the areas I had some discussions with were the air tool repair. At the air tool repair, we had an awful lot of air tools, of course, on these new jobs. Plus, the forge plant had a lot of heavy air tools in their normal operations, primarily, I think, for maintenance work and so on. Well, I could not send my multiple spindle air tools and so on. The plant 3 to be repaired, although that air tool group was very familiar with them. They had to be repaired by the forge plant air tool man. And he and I had some kind of serious discussions from time to time about what I expected and so on. And he was reasonably well skilled in what he did, but he had a lot of learning to do on these new type tools.
He was used to these big models.
Well, yeah. And again, he operated in the forge plant mode, which was usually any decent way to get it fixed, we'll fix it and get it back on the job. And so, but a lot of our tools and so on, you couldn't necessarily work quite in that vein with them. They were a little more sophisticated tooling. And he would not draw his parts from plant 3, although I think we had that option. So he had to set his own parts inventories up and everything. But eventually it worked out. But it was a kind of a rough year to get things going. And as I say, even though this front suspension area was pretty much a main plant operation.
Was it kind of viewed that even by the
Yeah, well, somewhat, because
they were forge plant people?
well, yeah, but it had been processed from the main plant, and all the engineers like Fred McGlone and Dwayne Severance, as I recall, had the welding and the machining on the rear axle and so on. And I think a lot of the stampings for the control arms and so on came from the main plant. I'm not sure where the cross member stampings came from. I have a feeling they probably came from the main plant.
Probably did. I can't remember that.
I don't recall the forge plant ever at that time getting into much stamping.
They're still just hot air.
Right, but they did the welding. All the welding was done in there on the cross members and so on. So there was getting to be more and more of a cross fertilization of processes and activities and so on. And by the time I left the activity, I think it was pretty well resolved. Some of the people like Claude Basing had been brought up, and I think was the superintendent of that area. He had come to the forge plant. But Claude was quite a sharp, one of the younger people, and appreciated what was being done and so on. I think, in fact, Claude went to GMI, if I remember right.
He was a college grad.
Yeah. And so Claude and I got along very well. And I found that most of the forge plant supervisors that I had contact with, the down on the floor maintenance people and so on, were just great people to work with. Even today, I run into them occasionally. But the sticking point was a little bit up, I think, at the higher management level, that they did not really want to lose any control of this. They wanted to be in complete control of that area. But I'm sure as different people were put in and so on, that smoothed its way out. So, as I say, I think I left Methods in 1964. And at that time, I just felt I had been there long enough, I guess, for one thing.
Kind of at your.
Well, oh yeah, it was at my request. I wanted to leave, and I talked to Bob Truxell, who at that time was the manufacturing manager. I think. No, I think he was manufacturing manager. Wasn't he? Is Rollis still there? Okay, then he was director of manufacturing engineering. Yeah, you're right. You're right. And so I told him I wanted to leave, and in our discussions, he said, "Don't do anything." He said, "I'd like to have you consider a couple of things, but I can't talk to you about them for a week or two yet." So I gave him his week or two, and because I did have a couple of other offers on the outside that were I thought worth pursuing. And so he got back with me and said, I've got approval now to set up an advanced manufacturing group. And he said, it did not exist. And he said, I couldn't talk to you earlier because I didn't have approval to do it. But he said, I'd like to have you consider it. And he said that Bill Martin, who was out of product engineering, who had done a lot of work in stress analysis and that type of work, was very good in that. We'll head this up and there'll just be the two of you. Okay. So he kind of explained some things that he wanted to accomplish, and I said, well, I'm willing to give it a try if I get some consideration. And sure. I did get a little consideration out of it, so Bill and I set up shop. Well, he wanted us to be a liaison with the advanced manufacturing group at the tech center, for one thing, to be aware of any new technology and so on that maybe was not being utilized at Oldsmobile, and also bringing in perhaps some new processes, new work, and so on. He just wanted us to kind of have an open-ended, big broad brush of manufacturing technology. So that really was extremely interesting. And as I recall, there were several smaller projects that Bill and I kind of divided up the work a little bit. He was a supervisor and I was a senior engineer, but we really never worked like that because there was so much area to cover. He went one way and I kind of went another way. But Bill, with his work and his knowledge in stress, and basically he had pretty good knowledge of automotive design in terms of stresses and so on. So he kind of went off in that direction on metallurgy and so on. And I took kind of more of the nuts and bolts type of programs. And one of the programs I remember that I worked on, although, like I say, we both were very close. We sat in the same little office, which happened to be right next to the men's restroom in Building 40. And it was an office, really, that two of us had to squeeze to be in. But worked on welding of the flywheel ring gear to the flywheel. Okay. The tech center, because it had to be balanced, and the tech center was working on some new balancing techniques and so on. That happened to be GM Research, GMR, as we called it at that time. And I kind of followed that one. And another one, we were trying to develop a hollow tube push rod, which some manufacturer on the outside, we got hold of some samples, was working on it. So we pursued that one, where you took a steel tube and welded a ball on each end, but the ball had to have a hole in it for the oil pass up through this tube. So I think we were working on trying to come up with a process with outside vendor to spin weld these little balls in the tube and still hold an accurate length, which was quite interesting.
Now, did you guys carry those things to completion, or what did you?
Well, the way we were to do it was carry it to a point where we were actually going to write the orders for the original equipment and so on. Get the process in, assuming it wasn't a huge program, and then while get it debugged and then turn it over to the respective production groups or production. And although there wasn't any hard and fast rule on it, I guess we could turn them over anytime a Truxell felt the production engineering group was ready to take it over. But we had to get these projects to a point where at least they agreed with our, thinking on them and the feasibility and so on. But the other large project that we worked on was what we called continuous casting or scrap utilization for the forge plant.
Yeah.
And I never got so tired of costing out the price of parts based on every doggone time the price of scrap metal would change. So I was always in Ed Vogt's office adjusting all the prices because we were going to make connecting rods, crankshafts, steering knuckles, ring gears, differential gears.
Axle shafts?
Axle shafts were part of the program, but the metallurgy on axle shafts is much more critical, as I recall, than some of the others. And
these were all going to be forged afterwards, sort of.
we were, yeah, now we didn't dare call it steel making because GM has a tentative or under the table or something agreement with the steel companies that they will not get into steel making. So I think we refer to it as scrap utilization. And the program was we were to take all the sheet metal scrap from the main plant. I'm not sure if we were to take casting scrap or not. I'm hazy on that, but I know we were to take all the sheet metal scrap and the forging scrap, and the program was that we were going to put in large electric furnaces, 3 of them if I remember right, and melt this, reconstitute it, as we called it, with the proper alloys, and so on. And then we were going to continuous cast it. And I think they actually went into that program at the forge plant pretty much along the lines that the original proposal was. In other words, you then took the molten metal and up to the, I think it was called the tundish, and then which was, I don't know, 75, 80, 90 feet high, and poured it. And as it poured down this stream, then it started through rollers and so on, and you actually ended up with a long, skinny bar. I'm not sure they were called billets or bars at that point. But I learned a lot at that time, of which I forgot 95% about metallurgy, but that in order to have a acceptable forging, I think you had to reduce the metal 6 to 7 times the original. So you got a little reduction in the bar itself as it went through, and then you had to rely on the forging process to, and that, I left the advanced group then, before any of the equipment actually went in. Well,
is that the kind of thing the truck still would dream up?
Or yeah, well, people on the outside, I remember we visited one of the first continuous casting machines in Dunkirk, New York. And it's a much, much cheaper way of making steel, much cheaper. And and there were people involved. Electromelt, I know, was one of the companies that had developed electric arc furnaces. And of course, with electric arc furnaces, you have much cleaner steel, and with the so-called open hearth, and so on. And there were people at this time, can't recall their names, developing the actual continuous casting equipment. And it's a process that right today is used quite a bit. I think specialty steels, smaller batches, and so on, because you don't end up with these huge, great big ingots that the normal steel mill produces. But again, as I say, most of these projects you're working on 3 or 4 of them at one time. So I left the advanced group before that came to fruition, but it did actually first go into operation at the forge plant. I think the price of scrap, as I recall, if the price of scrap went up, you became less competitive.
Because you could sell it on the
you
outside.
could sell it on the outside, and I think the price of scrap kept going up. Keep in mind, this was probably in the late or mid 60s.
Okay.
So when we started in, it was $18, $19, $20 a ton. I have no idea what it is now, but I know I was getting scrap prices every week, and it depends where you ship it and the freight. And it was kind of interesting to work on it. And I think Ed Vogt, I don't recall who his financial person was, but we had a financial person working with us to put these numbers together because it was a tough sell. I know to the corporation. It was a large investment.
You guys actually went through the process of turning in the program. And
yeah, I don't know how far that we actually got with it. I know we kept putting projects together with numbers and so on, because I do recall we had constantly getting quotes from the equipment people, and the forge plant people had to provide the estimates for the installation and so on. We did get involved, I know, with Board of Water and Light because there was not adequate power available at the forge plant for the big furnaces. What hours we would have to run them if there was any restriction on hours and things like that. But ultimately, although I know they put it in, they did produce, I think, side gears for the differentials. Axle shafts, I do not think they got in production with, but I could be mistaken. There's people around that would certainly have that information. But we started, well, then GM Foundry started to really give us a lot of competition on casting of cranks and knuckles. And I think we lost that business on some of the cranks, although certain engines, a forge plant was still, a forging was still required. Forging's a little better than a casting, as I recall, in terms of strength and so on. But the engines that they were starting to develop this time, I guess that's when they get into lower horsepower then, or lower compression or something. There wasn't quite as much load on the cranks, and but I had left the area by that time. But the other project that I worked on as part of that was the plastic project. And again, we were carrying these simultaneously. And I carried that one pretty much alone. Bill and I worked together on the continuous casting. In fact, he was very involved in that one, and I can't remember some of his other projects. You probably didn't get him in here some.
Right.
But I kind of carried the main ball on this plastic project, and we wanted to look at injection molding.
I hadn't done any of that.
No. There was no activity at all at Olds, and injection molding was just starting to be used in cars. So we got very close with the plastics group at the manufacturing development, and actually had several joint programs with them, because our success of this program depended 100% on their backing, because notably Guide Lamp, was 100% against an automotive division getting into injection molding.
Really?
Oh yes, they wanted to be the plastic division of General Motors.
Even for appearance kinds of things.
Oh yeah. And so someplace in the morgue file, there are a couple of kind of interesting letters that eventually got to us that Guide Lamp had written to their vice presidents and so on why they should be the plastic source for General Motors. So we had a couple of VPs that were lukewarm to us entering, mainly the VP, and I don't recall who it was. It doesn't even matter.
Yeah.
That the Guide Lamp group came under, because they were under an entirely different group. Than we were. But we kept pursuing this, and one of the kind of ground rules was that the parts that we developed, we could not take any business from guide lamp, even if they were in it. We could not take business from anybody. We had to develop new parts. So
Or a part of ours had to get converted
from sheet metal. So the original parts that we worked on were what we called we call them the filler plate then. I guess they later be called a wheelhouse panel or the skirts. Some division call them skirt bathtubs, but we always call it the filler plate. And we built 2 molds with the tech center, and had parts molded in Detroit someplace. And we started to develop a plastic fan shroud. I think Guide was maybe also working on a shroud, but not for us. And our shrouds were metal. So we started to develop a plastic shroud. So I recall there were about 5 parts we were working on. The steering column cap was a die casting.
Okay.
Well, it was just more of appearance. It was actually bolted underneath, and this little cap just flushed your dash out. Yeah. Working with one of the plastic companies, we found that we could maybe mold the hinge on the glove box, integral with the glove box. I think there was a plastic glove, most of the glove boxes at that time were cardboard and flop. But we worked on this program to mold it with the hinge on it. And in fact, somewhere in the morgue, you guys, there's a cost study after cost study, zillions of them on different ways to make glove boxes and what we had to do to get that business. And we also
oral history recording of William L. Larry Lennon of 1533 Smoke Drift Lane, Lansing, Michigan, 48917. This recording was made by Jim Walkinshaw at the Oldsmobile History Center on February 27th, 1992. This is tape number 2 of 3 tapes.
We started to work on nylon fender extensions, which were the little caps that went on the end of the fenders.
This would have been the first time we worked on
Yeah, they were die casting. Yeah, they were die castings at that time. And with this family of about 5 parts, and we kept making proposals to the corporation and so on. And we eventually got approval to buy a machine. It had to be a 650-ton ferrule, and I recall it was installed in Plant 3 in December of 1965. And the reason I recall the date so much is the machine and Gordy Crater, the first person we'd hired, showed up the same week, or very close to the same week. But anyway, we installed that machine and started to then pull the molds in and work on the fan shrouds, which I think was the first part we probably got into production. I think it just replaced the sheet metal one. So just when it went on the cars, I'm not sure. But shortly thereafter, we had 4 more machines come in before the end of 1966 calendar year. Another 2 more 650 tonners, a 1,000 tonner, and a 1,500 tonner. I know we used a 1,000 tonner on the glove box. I'm not exactly sure what the 2 other 650s were used. Maybe there was enough fan shroud business we used 2 machines. I'm not sure. But the 1,500 tonner, we tried to mold the filler plates. And for prestige purposes, political purposes, our goal was to get 500 sets on the 1966 Vista Cruiser.
Okay.
And the reason the Vista Cruiser was selected, as I recall some of the background data, it was a little more forgiving car. than the 4 doors and the 2 doors.
Forgive me for what matter.
Well, shake or something. It was a little heavier car or something.
A little more rigid.
And also, I guess we could control the Vista Cruisers a little easier. The volume was lower and so on. I'm not sure in my own mind if we ever actually got any on 1966 cars or not.
Okay.
We sure tried because we were the leaders of the industry.
Was it interchangeable basically?
Interchangeable with the sheet metal. Completely interchangeable.
Okay.
But some of the cost numbers I went through in this mess indicated I think we could save about $4 a car, which was tremendous savings back in those days. We did get them on 1967's cars, but not the whole volume. I'm not sure when we really hit the whole volume.
But nobody was doing that.
Nobody was doing it. We were the very first. In fact, Oldsmobile did actually get several awards for that. I keep saying Oldsmobile because this was all before VOC.
Yeah.
And I think we got an award for, let's see, 67, 20 years, 77, 87. Yeah, it had to be 20 years of having the longest running plastic part in production. Now, that doesn't mean identical part.
No, but
but the concept carried out at least through 87, and the Society of Plastic Industries gave us quite a nice award for that. So somewhere is in their archives and so on. And we actually sent some of these I think are in the Plastic Museum out in Connecticut or wherever it is. Yeah, there's a plastic museum. And so anyway, we kept building up and getting more parts. And once we started to move now. We added machines at a tremendous rate. The first 5 went to plant 3, and then we started to add them into building 52. And why don't you shut that off just a minute?
Right.
So from late 1965 until probably 1978, we added a total of 36 machines. The first 5 going, as I say, to plant 3. And then those moved over to the main plant probably in about 68, 69 along in there. We consolidated all the machines at the main plant, put in a bulk system, and so on. But one of the things back probably in well, we got our first big machines, 2,500 tonners, I think in 67. That would be these. See, there were 66 machines, which were some of the largest machines in the industry, and that was to permit us to put the filler plates on both the Cutlass Supreme and the 88s.
Were those bigger than or something? Why those wouldn't work on the littler machines?
1,500 tonner, really. We struggled to make the few that we made on it. Yeah, so we needed these 2,500 tonners.
Okay.
And at that time, our plastics facility was really the showplace of the industry. We had these large machines. We had innumerable tours through the plant, constant tours through the plant by other molders. Ford, Chrysler, had been through several times. And it was just a very good running operation. Of course, the machines were all new, ran well, looked good. Our handling system was very good. In fact, ironically, the handling system that was put in at that time automatically unloaded most of the machines. We had belt conveyors that ran in underneath or over the tie rods, depending on the particular machine, dumped the part on it, conveyed the part out to another belt conveyor running transverse, I guess, to the line of machines. That eventually got ripped out, probably mid to late 70s, and ironically, just before I left in the late 80s, they were trying to put the same system back in again.
Everything recycled.
Everything recycled, because it did have a lot of merit. It had, of course, some disadvantage. It was a little tough to manage a system because you had 4, 5, 6 different parts all flowing into one area for packing. And this could present some problems from a management standpoint and so on. But the system did have merit. And like I say, Olds had a very fine reputation, and it's as a very progressive and so on in the area of injection molding.
Problems now with the guide folks at this juncture, or had that?
No, so we got firmly established. We did take, I don't know if we took a grill away from them. We did take some parts away from guide later on that they had maybe made the previous part. We never took an active part. But let's say they had made a grill for the 1972 Cutlass, and the 73 was completely redesigned. And if it didn't need to be plated, because we did not, we'd costed out plating facilities several times, but we just didn't feel it was, the economics were there for Oldsmobile to put in plating facilities, because they can be in and out depending on a styling concept.
So our grills were basically the
Painted, yeah. Now later on, we did mold a lot of grills and send them to independent platers, but this caused a lot of problems. There was always concern whose responsibility is it if you've got a defect, and it was a very untenable, I guess is the right word, position for us to be in, because we could never prove that it was a plating defect or that was our defect. And so, although we did that for 2 or 3 years, I'm sure I think they're completely out of grills now because of part of that problem. You can't have 2 different sources involved, especially if the plater has molding facilities. Now we found if we could find a plater that was strictly a plater, not a molder, that you had a little better communications. But where the plater actually had molding facilities, economically it wasn't good, because he could charge you anything he wanted for the plating part of it, and you knew what the molding part was, and he could always undercut you on price. So it wasn't good. We did stay quite a bit in painted plastic parts that we could paint in the area and so on. And in the last few years, I left in 1988, spring of 88, I guess I didn't mention that. But we were getting into some of the quasi-structural type of front-end grill, let's see what's called, front-end grill mounting panel, I guess. Okay. And those type of parts, which are good business for us, big parts.
The injection molding stuff, Larry, back a little bit. How did product engineering view that? Were they having to make changes from?
Well, we had a very active group working with product engineering.
Okay. Did we actually promote the part?
Oh yes, very much. Gordy Crater, as I mentioned, who came in 65, had worked many years in molding plants. He had a very good handle on molding techniques, part design for molding, and so on. Okay. Ray Witter joined, I think, in the spring of 66. And Ray had been a technical service rep for Hercules, one of the large polypropylene producers at that time. Okay. So Ray had a very, very good background in materials and so on, what could be done with materials and so on. So with those 2 individuals and the reception we had with product engineering and so on, Otto Kern, for instance, was very much in favor of plastic. Bob Schultz at that time, we had fellow contact with Bob. Very far thinking, in their views and so on, what could be done as in the cost picture. So it was a good positive. Oh yeah, we had a very good relationship at Oldsmobile. In fact, we kind of formed a plastic group that was never really recognized officially, but with product and so on, and our management. Of course, Bob Rollis, Bob Truxell, and so on were very progressive. Truxell especially, I know he sold Rollis, and Belts, I think, was quite receptive to plastics. He was far thinking, so you had a very good a team effect there. So when these plastics projects went up, our management just didn't say, "Oh, I'll go ahead and submit it." They supported them through the corporation. And we had also kept our relationships with the manufacturing development people. So we tried to work with them, closely with them, and keep them informed and so on, so they would support our projects. Because there was always some reluctance, to spend money. And then at this time, Buick and Pontiac and even Cadillac got into injection molding.
Okay, so everybody, all of them started doing
Everybody eventually got in, which helped us a little bit, but it hurt us a little bit because it didn't give us avenues to mold for Buick and Pontiac, of which I think we had at one time done some molding for them and so on. So, but the injection molding is pretty much maintained the status quo through those years.
No, it had some unique things there. Like you made red filler plates.
Yeah, I knew you were probably going to ask that, and Ray and I talked about that one day. What model was that? And I don't know. There's some concern. It was about the 69 or 70.
70,
yeah. Now, I think one of the unique things that maybe isn't remembered on that, and I'm not positive this statement is correct, but I think they were made out of either Coca-Cola red or Prince Albert red.
Really?
Yeah.
Now, was that
the
color that you mixed in?
No, Coca-Cola has a red exclusive color.
Yeah.
And so does Prince Albert on their cans. Right. Well, they had both gone into certain plastic products. I don't remember what they were. But anyway, those colors then, when we went to select colors or products, selected colors, they were readily available.
Oh, I see. Okay.
Colors because the plastic people had been making them. So it was natural that they just shoved us those colors to try out. There was nothing proprietary about it.
Yeah, because it's just a color.
It's just a color.
Yeah.
And our product people, again, had we weren't working any color charts on those, so if they liked the appearance. And I believe it's one of those two colors. The only thing I can find is I still got some old plastic cups around my house that I know are those colors. Now, whether or not those were the filler plates, or we could have actually ended up with a different color, but I know some of our early moldings were those colors.
Did we as manufacturing guys propose that to the product?
No.
Did somebody think we ought to try that?
Yeah. Well, they on this particular car, I think it was probably a W30 or W31. Yeah, one of those limited volume cars. Wanted something to dress it up a little bit, and it seemed like they had at one time tried to paint some sheet metal filler plates, and of course it just didn't have the durability and stones and so on. So apparently someone over there in the styling group kind of always had this in the back of their mind. So when we got into this, they asked if we could do it. Well, we could. It was a very easy thing to do.
Nothing had to be changed manufacturing?
No. With the colors, the way we used them and so on, you didn't get into different shrink factors or anything. So no, was no problem. And it did. There's you may have them over here, but one thing before those departments get completely torn apart, there's a lot of files, slides, and pictures you probably ought to get your hands on. You ought to capture them. And I know there's several views in there that show these filler plates laid out with the red one and the black ones and so on. So anyway, one of the other things I wanted to touch on that probably is not too widely remembered was back in '69, we decided to get into blow molding.
Okay, this is like milk bottles.
Yeah, only we were going to make the heater and air conditioning duct. And as I recall, that duct had a center section that fastened on top of either heater or air conditioning, and presently then I think that may have been plastic, or that could have been sheet metal. And then they bought some convoluted paper or cardboard to give them the flexibility to get up to the defroster outlets. And we thought we could blow mold that.
All right.
So, and make this all in one piece. So we contracted with a German firm by the name of Kautex in Bonn, Germany, or they were actually just outside of Bonn, a small town called Siegburg, if I remember right. And they had a complete operation. They made blow molding machines, they made tooling, they made the trim fixtures, and I believe they had a molding plant, or they had some relationship with a molding plant. So through their American representatives, and again working with product engineering, we had a part designed, and I think we talked to a couple of American companies, but we had to split the order up to tooling and equipment and so on. None of the American companies at that time were really very integrated. And basically they were into bottles and consumer type product and so on, not too much in the automotive development facet. So we hooked up with Caltex, and they kept missing their lead time. So Ray and I went over. I remember in the fall of 1989, we were to have a runoff. Excuse me, 69, yeah. And so when we got over there, the machine was not ready, the molding machine itself. But that didn't bother them. They had other machines, but the tooling wasn't quite ready. So Ray and I hung around for 3 or 4 days. Well, we had actually, before we got there, set up some other places we wanted to visit. We'd had, as I mentioned, when our activity was getting a lot of publicity, we'd had quite a few French people in, English people, and so on. So we called in our markers and visited their plants and saw some very interesting things that they were doing. And so, but anyway, we ended up in at Caltex. And the tooling wasn't quite ready and so on, but it looked very promising. And I remember with a little arm twisting, and why I don't know, we finally got into their blow molding plant. And saw some very interesting things there, things that they were doing on German cars. And came back and so on. And I think the machine and the tooling showed up probably not until March, maybe April. I don't know just when, of the following year. And blow molding was completely new to Oldsmobile. And unlike injection molding and later on SMC and so on, which I'll get into a little bit, management had been quite receptive to allow me, I was a supervisor of the activity, to hire experienced people from outside GM. And just as a sidelight, some of our other automotive divisions that got in didn't do that, and they struggled for years.
Oh, really?
But as long as I could make a good case in point, we were permitted to hire experience. Well, blow molding was kind of shaky, and we did not hire experience to do it, although both Ray and Gordy had a pretty good handle, Ray especially on blow molding because of his material experience. And materials used in blow molders are similar to materials used in injection molding, same family materials, slightly different properties. So Ray had a fairly good knowledge of at least the material aspect and so on. And we worked very closely with Phillips Petroleum, who in this country were probably the #1 material supplier of blow molding. In fact, Phillips ran several blow molding plants. They owned them. And so they had quite a little experience, and we were sure we could get help there if we needed.
Help us on the technical side.
Yeah, they'd help us on the technical side.
Okay.
But we got the equipment in, and as I recall, just due to the materials and the technology at that time, keep in mind this was 20 years ago, we could never quite get the flexibility in these convoluted sections that we wanted and get the stiffness in the rest of the part we had to have.
Oh.
Now, with today's technology, the way they can automatically program pairs in and so on, you probably could do it. But pairs in programming at that time was in its infancy. And even though we had it, as I recall in this equipment, it was crude.
Which is what, though?
Well, it allows you, as this Parison drops, to change the wall section. So that as you blow, well, that's the tube of material that comes out of the blow molder.
All right.
And then you close the mold up, and then you introduce air or some gas and blow this material out into the form of the mold.
It's the basic material.
Yeah,
the mold.
Yeah, right. And it's not a liquid like injection molding. It has
body to it.
It has some body to it. So modern equipment nowadays, they can program this Parison to give them thin, thick sections, and I think they can even side to side, which we could not do. I think we could program a little bit thin to thin over the whole length. It's amazing what computers have done.
Isn't it remarkable? Yeah.
So we were really never able to get it. So then we said, okay, we'll chop the convoluted sections off, and we'll make those separate, still out of plastic. And we worked on that, and I think somewhere's in these notes I found it. We worked on this for probably a year and a half, 2 years. And the product designs had also changed during then. So we were always trying to leapfrog to the new design and so on, but it just never really proved itself. And I think another thing was happening is outside blow molders were getting established more in the automotive, and again, our burden rates had started to increase rather significantly during this time, so our costing structure. And when you're competing with an outside molder, if your process is exactly the same as his, same material, and so on, and our burden rates, labor rates, and so on were higher, you just cannot compete. You've got to have something unique. And this blow molding at this time really wasn't that unique. So we abandoned the project. In fact, the machine sat there for 3 or 4 years before we finally were able to sell it to somebody. But we did try.
Sure. And nothing ventured.
Nothing, yeah. And again, that probably is not remembered by too many people because it never really got into production. Okay, let's kind of change horses. And the next area of plastics we got into was SMC, or sheet molding compound.
Okay, which is
well,
reinforced fiberglass.
Right, polyester reinforced fiberglass. Right. And again, we tried to be unique.
How did that get trained up?
Well, we hired Warren Diebold, who had worked on the Corvette and the Avanti, which was a Studebaker car. Yeah. Now these cars at that time both used reinforced fiberglass, but they used what's called the hand layup system, where you actually put the resin in a mold, you put the fiberglass in as a mat.
Like in a bathtub.
Yeah, and then you close the press up, and with heat and pressure you form this part, and then you have to trim it and so on. Well, with SMC molding, you actually make a sheet, an impregnated sheet of material, which we bought the machine for, and so on. And then you cut this sheet into some configurations, and then you stack these sheets, which is called a charge, in a mold, a hot mold, usually I think about 300 degrees. And then you close the press up. So in theory, your material is all inside the mold and it flows to the extremities and so on, but you don't have that solid matte appearance. So from a manufacturing standpoint, it's much cheaper. You don't have all the hand labor. From a part standpoint, it has some disadvantages due to the glass orientation.
You don't get the big long fibers.
You don't get the big long fibers, and I think at that time we cut the fibers all at 1 inch length back on the machine when we made the sheet. Although we had a random distribution throughout the sheet, it could flow. So it took a lot more technology to develop your parts and so on. But we had made a lot of studies, and at that time, I think the 1970 or 71, 88, 98 had either 11 or 13 parts, cannot recall just which, that made up the front end panel. Sheet metal, weldments, fender extensions, and so on. By this time, we had abandoned, I didn't talk much about our nylon fender extension program. It just, regressing a minute, what we ran into on that of all the strange things, we could make the parts.
This was an injection molding.
Injection molding out of nylon, but nylon has to be dry.
Dry, you mean humidity dry?
Yeah, well, the material, it's hygroscopic. It will absorb moisture. Yeah. So when you mold it, you have to have it very dry. And but when we molded it and then sent it through the paint plant, of course, the paint ovens kept it dry. So we found when we put it on the car, then it was a dry part. And of all things, if you recall, a lot of the parking areas they used to have heavy chains.
Yeah, right.
Signifying where the end of, well, if they ran into those, especially in the winter, they'd crack them because it would usually take 2 or 3 months for nylon to absorb humidity out of the air. To be.
It had to have the humidity or it was.
Yeah, nylon is very brittle. Well, a lot of your parts that are, this is some years ago, I haven't followed nylon, that are made today, they actually moisture condition after they mold them. They will put them in humidity. And then once it's in, I don't remember the percent moistures or anything, but it gets very tough. So the nylon you have around your house in the normal humidity conditions, although your humidity is low, is a pretty tough material. But if you bone dry that,
which you would get in a drying oven.
it you get in a dry.
Get all that in a drying oven.
Yeah.
Dry as a bone.
Dry as a bone, so it's brittle. And
but that was temperature. It was a phenomenon of cold weather, basically.
Well, the cold weather, your humidity is lower. Okay.
So that just compounds.
You're right. Yeah. In a hot, humid weather, it might in 3, 4, 5 days pick up enough. You didn't hit it, that it'd be all right. But anyway, we had kind of abandoned the nylon program. There were fit problems on it, and well, I guess we solved the fit problems all right. But one thing that in all these exterior panels that I probably should mention at this time, SMC is notable for it. Anytime we're matching to a sheet metal part, the plastic part can be exactly to print. If you want a very sharp peak radius, you got it.
Yeah.
Well, when you're matching to a sheet metal part, it cannot meet the print. You cannot put sharp peaks on sheet metal. There's always a radius, the crumb. So we had to learn that the hard way, that we could not design our parts to the print. Because so we really had to almost wait till the sheet metal people had made the hood, the fender, or something before we put our peak lines and so on. And this was also true of the SMC front end panels, where you had to line up with waterfalls and peak lines and stuff. But anyway, as I say, we had.
What, Larry? Back
Yeah.
up again. The SMC thing got started, but for a reason. What,
Cost savings.
basically cost?
Yeah.
Okay.
As I started to say, we looked at, I think, the 1970 or 71. Could have even been a 69. 88, and there was either 11 or 13 pieces that made the front end panel up. Most of them were stampings, welded in reinforcements, but I think it also had 2 fender extensions on it.
All right.
Because I think that was maybe the extension that we had been working on, because we worked on both the 88s and the Cutlass Supreme extension. 88 was a long, kind of skinny one,
Yeah.
and the Cutlass Supreme was a L shape, inverted L shape type. And at least on paper, our savings were just tremendous because we could make that all in one piece. We could even form, although this was a little bit beyond our scope maybe initially, we felt we'd even form the headlight cans and everything, which we ultimately did. So we eliminated the separate headlight cams, fender extensions, all this, and made one piece. So we started to work on this, and this was primarily due to Warren Diebold's expertise and so on.
Had we hired him to do that, or
No, I think we had hired him. We had gotten interested in SMC. The Tech Center again was looking at it, and A.O. Smith over in Ionia at that time, which was the old Mitchell Bentley and General Tire and whatever iterations they've gone through, had a line, so a sheet line, and we'd talk to them. Again, they were starting to put SMC on the Corvette versus the hand layup in some parts.
Didn't you make a fender?
Well, that was it. So the first thing we started on then, well, we started on 2 parts, and I'm not sure the exact model year, but I think it was the 1970 station wagon rear wheel skirt.
All right.
And the Tornado Valence.
Valence panel. Oh, yeah,
Valence panel. Yeah. Okay, we had no equipment at that time, so we actually built a mold, and Owens Corning ran half the valence panels in on their lab machine down in Granville, Ohio, for probably the 68 Tornado. Could have been the 69, right in there. Our press wasn't in yet.
All right.
As soon as our press came in, the first one that came in of all things was the 4,000 ton.
The big one.
The big one. Yeah, 4,000 ton clearing. And that must have come in at about 1970. So in the meantime, we had developed this little skirt mold. So we put that little skirt mold in that great big press, if you can imagine. And the press was originally designed so we could make hoods. Even at that time, felt that down the road we'd be making hoods.
But we hadn't done that yet.
We hadn't done that yet. No, that was just one of the projects that, because hoods were being made, like for the Corvette and so on, but with the hand layup process and so on. And so anyway, we started to work on this wheel panel. And I think our station wagon volume was something like 40 cars a day or something. I think then they didn't all get even the wheel panel. That may have been an option on it. And 40 or 70, it wasn't very many. In theory, if everything was running right, we could run out a week's supply in about 3 hours, which we never did. But we did learn a lot. And we were buying sheet, as I recall, because raw material, because our own sheet making facilities, although they may have been installed by this time, the volume was just so great that the wastage just started up and shut it down and so on. Although we did it, hardly justified. Because once you start that sheet facility up, you like to keep it running. And also, there's a definite time factor between when you make the sheet and when you mold it, which I think in our case was 72 hours. You actually formulated the sheet for when you wanted to mold it.
Something happened to it?
Yeah, it maturates. The resin catalyst phenomena starts to work in the sheet. And it starts to get harder. So the longer it lays around, the harder it gets. And I don't remember the numbers anymore we were working to on. Had to do with viscosity of the sheet.
You wanted it kind of hard.
We wanted it hard enough that you could handle it, not so hard that it wouldn't flow. Right. So it took about, as I recall, the original formulation, about 3 days to get to that point under controlled temperature and humidity. If you recall, we had the maturation room where we controlled temperature and humidity. No, well, you could formulate for any way you wanted to do it, but you had to be consistent. So we had to keep the room, as I recall, at a temperature and humidity condition that we could maintain year round. So we didn't necessarily want to take it up to 110 degrees. No, so I think we maintained at about 75 to 80 degrees. Yeah, because even in the summer, then you would have problems keeping it down to that temperature. No, I think we kept it at 90. Maybe it was 90. Because I don't believe we had any means of cooling, means of heating, but no means of cooling. So I think it was 90 degrees, Jim. But after 3 days, the material was molding then, but we were on what we call a viscosity curve. And the material kept increasing in viscosity. So as an example, maybe after 7 days, you couldn't mold it.
It was just too hard.
Too hard, yeah. And again, we were learning our skills.
So this is all stuff that nobody did about. Basically.
No, well, every manufacturer was different. Let me put it like that. And our sheet was about, as I recall, about 3 times as thick as anybody's.
Oh.
So we felt with a much heavier sheet, we didn't trap the air between the plies and so on, but it gave us different curves. And then we were rolling, I think, in 900-pound rolls at that time, 48 inches wide. And most sheet was 24 inches wide and about 300-pound rolls, thin sheet. So we had an awful lot to learn, but we felt from an automotive manufacturing type production. And by the way, Guide Lamp was in SMC at that time. Yeah.
More help.
Yeah, lots of help from them. Although by this time we were starting to establish relationships with Guide that we weren't going to put them out of business. They weren't going to put us out. There was enough business out there for both of us, and we were not particularly interested in some of the panels that they were making.
So the adversarial relationship.
Yeah, it was, going back on a individual basis. That is, I could call up my counterpart and he'd talk to me.
Yeah.
Maybe Rollis's counterpart wouldn't talk to him, but we were establishing a relationship. In fact, it turned out in the end to be a pretty good relationship. We helped each other quite a bit. And also they were in RIM, but I won't get into that one. Yeah. And but we started to make these wheel panels, and needless to say, there were some problems. And one of them I recall in particular that I don't think we ever solved was the panel had gone through several design changes and so on but it had a series of ribs behind it. Stiffening ribs, yeah. And then over these ribs, I think on the upgraded model, at least half the panel, or maybe the whole panel, got covered with a vinyl applique.
Oh yeah, right. Remember? That wood grain.
The wood grain.
Yeah.
Well, we found in cold weather, due to a change in temperature, static electricity or something, you could go out on a cold day and see those ribs from 500 feet away.
Really?
Yeah.
It showed right through.
Yeah, and you couldn't feel them, but it had to do with the thickness of material, and I don't know. We really never solved that problem. And as I remember, you also got into a phenomenon with dirt. If you would drive down a dusty road or slightly moist, that whether or not we had a charge on the panel got a charge from the, I don't know.
You mean it just kind of collected on the, you could see stripes?
Well, I think I don't know if it collected where the ribs were or where the ribs weren't.
You could see the stripes.
Yeah, you could see it. The average customer probably wouldn't even object to it on a dirty car.
Yeah.
Or even a cold, wet car. But it was just one of the things that we really never solved, but it did tell us that when you got into other parts,
Watch
that
out.
watch out, that you can, because the back of that panel was like a big checkerboard for stiffness, because it took quite a beating, you know,
It's a
with
lot.
rocks and changing the tires and stuff. You had to take it off and so on. But that was our learning curve, and the
Parts that were less high volume in limited applications, was that a?
we did on that one. But the first thing we jumped into with both feet, I think, was the 1972 BC front end panel, high volume. And I think you were around at that time. We had everybody's brother helping us on that one, because we built double cavity molds, which had never been built before. And one of the phenomena of SMC, and again, we were learning, was do you try and keep the material all inside the molding part, or do you flow across certain areas to prevent glass orientation, then pierce it out?
Oh, okay, like punching out a big hole.
Right. So the first panels we made, double cavities, were completely molded solid, and we built pierce presses that separated the two panels and pierced out these big grill openings, which were probably, each panel had two of them, typical Oldsmobile design, probably 10, 12 inches by 14 inches or so.
Big hole.
But when you punch them, you don't always get quite as clean a punch as you'd like, even though you have a return flange and so on.
You're punching glass, sure.
Well, yeah, it wears your tools out. You have to use hardened tools. But it does give you a pretty good flow pattern. But this material got punched out with all wastage too.
Yeah.
So I think on each panel, and there's always some flow of glass outside of the edge, even though you have a shear edge. We were probably wasting, I don't know, 2 pounds, 2.5 pounds of material.
That kind of like a quarter of it, maybe.
Well, 20% maybe at that time, 15, 20%. And it's waste. It just,
There's
no use for it at all, because it's already been molded.
Can't grind it up.
No, you can, but it's more expensive to grind it up. And then what do you do with it? You know, in fact, I was reading Tech Center is still working on ways of grinding it up and separating out the glass and calcium carbonate and using it as a filler or something. But I can't even, there's a name for that process, but I can't recall what it is. So anyway, but we got into the front end panel and we had problems. The first thing I think we did is we built new molds that separated, or maybe we reworked. We had 2 or 3 molds because of the volume. That time SMC was considered about a 2-minute process. So you get 30 parts an hour roughly per mold. Well, the BC volume was, I don't know what it was at that time. It was a bunch. So we probably had 2 or 3 molds at that time. I think we either started to convert them or we built a new mold or something. It did not mold in the grill opening and so on. And that presented other problems. And then we started to get problems with glass orientation and cracks in corners.
Because it was not flowing a lot.
Right. And it couldn't flow across the opening, so it had to flow around the.
Oh, yeah.
And I can remember spending hours out in the yard with Mooney and everybody else looking for cracks in front end panels. And again, we had no knowledge to speak of whether these cracks would propagate, although we'd run a lot of shaker tests with product engineering and so on, and put known crack panels on the shakers and so on. But you really never knew if they were going to propagate, whether the customer was going to have a problem. Some of them, I'm sure, the great majority probably never propagated, but you couldn't chance it. So cracks were a problem to us, and eventually you get smarter and smarter and change glass length, maybe change the resin formulation and the charge pattern, the way you put the charge in the mold.
A lot of trial and error.
A lot of trial and error, and you solve one problem, but maybe you create another. And so SMC has always had a somewhat of a problem on porosity, which would never show up until after painting.
Okay.
And it's what the theory usually is that you trap air in the panel.
Okay.
And it's always described as like a flask. You may have a very small pinhole opening, but then you have a void
Bigger hole
in the panel. And the theory is, or one of the theories is, that then when you paint, solvents can get into this void.
Yeah.
And then as you put that panel through the paint oven, and keep in mind these were all car-colored painted part, it blows a hole in the paint.
Because the solvent's trying to get out.
Solvent's trying to get out, trying to expand. Now, whether it's solvent or air, and worked with some people at research. One of them was Dr. Dale Cheever. Did a tremendous amount of work on this phenomena for years. I don't know, maybe he's still working on it, but he has come up with many, many elaborate means of analyzing the gases that are in these, and even though you may know what causes it, it's
how do we fix it?
How do you fix it? Yeah. Well, one of the fixes is usually to put an air dry repair on it. But the assembly plants would always fight us on that. They did not want to sand off these little pops.
Yeah.
And spray them with an air dry lacquer and polish them down.
Yeah.
But that, of course, is a fix, and so on. We tried all kinds of different primers, harder surface primers that maybe couldn't blow, two-component primers. I hope I'm not getting these confused with what went on in urethane, because urethane has some of the same problems. But the problems were never, to my knowledge, 100% resolved, but they were certainly more than resolved to a point where it was a very commercial process.
We made every car that way eventually.
Oh yeah, and
100%.
And closed up the SMC, I guess, when in 91 or something, or no, 90, I guess.
When they were using front end plants.
Well, they didn't know. They closed the business, said they weren't competitive.
Oh, is that?
Oh yeah, put in all that new equipment. Ray will have to bring you up to date on that part of it. That happened all after I left. But again, it was I think a reasonably good operation, and we ended up, while I was still there, I think with 7 presses.
Did we ever make hoods in house, Larry?
Yeah.
Scoop hoods.
We made a few of those.
Were those made by outside guys?
Both. We tried to develop a one-piece hood. Was our main thrust. The hood that was basically made back for the W30s and 31s that had the scoop in it. I think we made some. I'm hazy on it. But yeah, at least we owned a hood mold. But we tried then to take that outer skin that they had and make a ribbed inner to get rid of the sheet metal inner, because with the hoods that were used at that time for these sport cars, if you want to call them that, or high performance cars, had a conventional sheet metal hood inner that maybe had a little rework. And then they bonded that to the plastic outer, glued, yeah. And then it was painted and processed, just like the normal hood. So we felt there were considerable savings if we could actually mold it in one piece. So I know we worked on that program for years, off and on different models. But again, we ran into the problem of being able to read the ribs in the hood. Well, one of the answers is, could you style a hood so you had some external something and reinforce behind that? So that got back into the styling concept, and so on. And I don't know if they ever developed. I think the one-piece hood finally got pretty much abandoned. It was just, and the hood that I think they ended up making just last couple of years ago was on the Cavalier, that it was two-piece, but it was two plastic pieces, I believe, bonded together.
So your ribs were on the engine.
Yeah, because there was a case where the sheet metal inner didn't exist. And the old W30s, you could just take a conventional sheet metal inner,
punch out that big hole.
a little modification to it, use it. Well, I think when they got into the sport hood on the Cavalier, or whatever hood, I think it was Cavalier, I don't believe a sheet metal hood existed, so it was cheaper to tool an SMC hood inner. And because they had to be bonded together anyway, even though the SMC material is a little more expensive, it was low volume. I think they probably costing said it was cheaper to do it that way than tool up a sheet metal inner. But we stayed in the SMC business for almost 20 years.
The SMC thing, Larry, must have been kind of nice from the standpoint that you could make a volume for a low volume car. And
so that's yeah, some of the big, as I recall, and I had to go to several meetings and put on presentations. The advantage of SMC were it wouldn't, number one, it wouldn't rust. Number two, it was lighter. Number three, you could do things styling wise that you could not do with sheet metal. Or if you did it with sheet metal, it was tremendously expensive because of all the welding and the different fabrication. And you could mold it all in one piece. And the fourth one was that you could do it all in one operation. So if you were in, we used to have curves all the time, and I'm a little hazy on the numbers, but I think somewhere around 50 or 60,000 units a year you could do with one SMC mold. And then if you had 120,000 or something, I don't just remember the breakdown, but it took two molds. Well, you could buy a sheet metal dies, but you know, they'd probably give you 400,000 or 500,000. And if you're only going to 60,000 of a car. So the SMC tooling was much, much cheaper on that basis. Although tool for tool, it probably wasn't that much cheaper, but for sheet metal, you might have needed 4 dies.
But per car, it was cheaper.
Much cheaper per car. And so that's why it gave the styling people a lot of flexibility. In fact, if you look back at the Oldsmobile models, it would not be at all unusual some years to have 2. Once in a while, I think on the Cutlass, one year we might have 3 different front end panels. One was extremely low volume, just slightly different, and 2 other volumes, like the station wagon might have had a slightly different panel, and the 2-door and the 4-door is different. So anyway, it gave the styling people a lot of flexibility, and it gave them a fairly quick fix too. If, for instance, they didn't like the styling on a car, we probably in less than a year, depending, you know, how much of a crunch was on it, could have retooled a new panel. In fact, with going all out, you probably could have changed it in 6 or 7 months. You know, if that was your only change, just to tool up a new,
transfer to a sheet metal die.
to give them a new appearance. And so I think it was a good process for Oldsmobile for product. I still see a lot of them running around town, and surprisingly enough, most of them still look pretty good.
Unless you run into somebody.
Yeah, then you beat them all to heck. But again, it's repairable to some extent if you know what you're doing. In fact, one year, I'm not sure which it was, the service department came up with a procedure that usually, I think most cars get hit in the left front as a general rule, more than the right front. So some of the dealers were complaining that they had to buy this whole panel because they just wanted the left front section, maybe a foot of it. So seemed like we took all of our scrap panels And if the left front was good or the right front, we cut them off
Oh, really?
for a while.
And offered them to the service organization?
Some such thing as that. They wanted us to, and we didn't even have to mold a separate one, but it gave the a dealer then, in fact, saved him quite a bit of time because he could just bond it together. And so I think we molded lines. I'm really hazy on this on the inside. I'll show him where to cut and so on. Yeah. Yeah.
So, a lot of problems with fiberglass and people.
Yeah, at that time,
It's not been a known.
well, I'm still not sure anybody recognized fiberglass as being a carcinogenic material. They've always recognized it as an irritant.
Yeah.
And we actually got into fiberglass in injection molding, I think, before.
Oh, did we?
Yeah.
Okay.
I found some old letters in there that was quite a cost savings that we were buying, and this was really shocking. We were buying asbestos-filled material.
My goodness.
And that time nobody thought anything about asbestos being a problem. But asbestos is quite a cheap product in itself. But you could take an example, maybe the basic resin was 25 cents a pound at that time. Then you put asbestos in it, 3 or 4 cents a pound asbestos, and they charged you 40 cents a pound for the material.
Oh.
So this, I could really never understand talking to our material suppliers, but I think it was kind of supply and demand.
Yes.
So we started to talk to Owens Corning Fiberglass, and fiberglass maybe was 50 or 60 cents a pound. But they would sell us what they called, now I gotta stop thinking between rim and, because rim uses fiberglass too. There was a flake glass and there was a short fiberglass. I think they would sell us short fiberglass, which was maybe a quarter of an inch long. And they had developed a piece of equipment to blend, okay, here's where it's come back, flake material that Hercules made. Now, backing up a little bit, normally for injection molding, you purchased a pellet, about a quarter-inch long pellet, maybe an eighth of an inch in diameter, and so on. Well, to make that pellet, excuse me, the resin people go through a reactor, and out of that reactor, they get a material they call flake. They don't call it powder, they call it flake. Okay. And then they take this flake material, stabilize it, and put it through an extruder and make it into a pellet. Okay. Well, Hercules made us a proposal that if we could use the flake material right out of the reactor, it would maybe save, I don't know, 5 cents a pound. So maybe instead of 25 cents a pound, it was 20. And then we would have to put our own stabilizer in it, which they would sell us the stabilizer package. So then talking to Owens Corning when we started to get this thing going, they had started to develop a blender to blend fiberglass, flake, and stabilizer and color together. Well, when we put all these numbers together, it looked like our material maybe was going to be 27 or 28 cents a pound. So again, there's some letters kicking around on how much we could save. And at this time, if we'd have known what we knew now about asbestos, there'd been no question. But back then, it was strictly cost. That's right. But even then, I think it would save about 15 or 18 cents a shroud. And I found a letter I'd written to Mooney.
This is an oral history interview with William L. Larry Lennon of 1533 Smoke Drift Lane, Lansing, Michigan, 48917. The recording was made by Jim Walkinshaw at the Oldsmobile History Center on February 27, 1992. This is tape number 3 of 3 tapes.
Okay. Owens Corning had in their laboratory, which by the way was the same laboratory that molded the the other end of it that molded the valence panel
Okay.
in the SMC. A piece of equipment made by Littleford, they contracted out to Littleford, if I remember, to blend these materials together. So we again talked our product and got them to approve the material change. We molded. I guess we had somebody pre-blend material. Might have been Owens Corning, and we brought it in and molded it. And it was all plus. The properties were better than asbestos, higher tensile strength, better impact. So, but it was a matter of getting product to change the spec on the print. So there's some letters requesting they doing that with the savings, which I'm sure they did very quickly. And Owens Corning then gave us a piece of equipment on consignment. So we still painted their color. And I do recall when it came in our plant, it was a very dark green, not our Dista green, and everybody wanted to paint it. And one of those sidelights, I kept telling them, well, you can't paint that. So we had to go out and have property of OCF stenciled all over. But anyway, we got into production on it, and it worked.
But now we're dealing with fiberglass.
Now we're dealing with fiberglass. No problems. No one ever complained about it. But it was a rather tricky process. You had to stay right on top of it to make sure that your percentages were correct, especially that the stable. I think, okay, here's one other plus I forgot. I'm really guessing.
Okay.
That the stabilizer package was much more critical for asbestos than fiberglass.
Oh, all right.
That polypropylene, without that stabilizer and with asbestos, will deteriorate, which the resin company knew and we knew. So one of the checks we always made, Ron Ratajak that time was in the laboratory, and every incoming batch of polypropylene, we checked it for the stabilizer. But anyway, then when we got into fiberglass, fiberglass did not have quite the detrimental effect. Stabilizer was, I think, still important, but maybe not as critical. But anyway, we put it in and started to make fan shrouds, and eventually we made some filler plates for the station wagon. They wanted a little more stiffness.
Okay.
And I think maybe I forgot to mention the converter pan was one of the original parts we tried to develop, but it took us 2 or 3 years to get it going because every time we'd get close to it, the engine heats would go up, and the converter pan laid right along the exhaust pipe and fastened right on to the back of the engine. So it got all kinds of heat, hot oil. But we finally got the converter pan developed, and I believe that was made out of glass reinforced fiberglass too. So anyway, that material stayed in use for many years. In fact, I think the equipment was just pulled out in about mid-80s when products had changed and so on. But anyway, that was our first experience with fiberglass, and you could go down in building 52 and on a sunny day look up in the skylights, and you could see it, but
just floating in the air.
Yeah, just floating in the air a little bit, and very, very few of the operators ever complained. And so Owens Corning is a pretty much environmentally conscious group, and unbeknownst to us at that time, they were doing a lot of work on it too. So, but they started to keep us informed that they said they can find absolutely no carcinogenic problems with it, but it can be a skin irritant. That we may find some people that it would irritate the skin, although usually not just what little came out of the mixer, just from the mixing, because I think the mixer had a cover and everything on it.
Okay.
But when it came out of the slide into the box and they dumped it, yeah, it was quite well contained. But I think there may have been 1 or 2 women that worked around the parts or something that did have a little problem. I'm kind of hazy on it. I try to stay out of those areas because they were hygienic and so on, as long as we felt comfortable that we weren't exposing operators to anything that had any detrimental effect. But then out in the SMC room, of course, when we started to get an SMC there, we were chopping fiberglass by the tons in those automatic choppers. And again, if you want to get any of the nitty gritty on the SMC, you probably should talk to John Wright, because we hired John from A.O. Smith.
Is he still with us?
Oh, yeah.
Excuse me.
John had been active in their SMC room. So John, we brought him on board. We had Warren at that time, as I say, and John actually followed the building of our SMC machine and everything.
Oh, yeah.
All things built out in Salt Lake City, Utah. And it was one of the, I think it was very unique at that time, as I mentioned, due to the width and the weight of the sheet. And there's some quite unusual features in it, some quite advanced features in the way the material was kneaded to mix the fiberglass resin and so on and make the sheet and so on. So John can, if you want details on that, John can bring you up. So anyway, that kind of brings us up, I think, through SMC. We would find in our parts, especially parts, this was always frustrating. I can recall the Cutlass Supreme at that time, I think, was made in Arlington, Texas, Lansing, Michigan, and Doraville, Georgia. And with the same batch of parts, one plant might have a problem and the other two wouldn't. We thought it was. Well, I spent a lot of time in those plants, especially Doraville. And the only thing we could ever crack down was paint process. That, yep, oven's hotter, different type of primer they were using, just different things. And as I think back, at Doraville, it seemed to be the #1 plant for problems.
Maybe it was too damp down there.
Well, I think it was their ovens, and Doraville always thought they were building the highest quality car of the 3 plants. I think other people might have questioned it, but they tried to build a high quality car. And maybe they were nitpicking a little more on some of the things that they were doing. They might not like to repair. No plant likes to repair. But Arlington, as I remember, which of course in a lot of news lately, but pretty much took them as they got them, and I think they ran their ovens maybe a little lower temperature. It could be too, and I don't even recall anymore how the position the panel was in. You see, like in Lansing, we had the separate paint facility, if you recall, where the hoods and fenders and front end panel went through. I'm not sure that Doraville didn't run them all through one oven bodies. Well, they might not have been all assembled, but they all, yeah,
sort of together.
Right, that they maybe had a buck, but I'm really hazy on that. It traveled with the body. So maybe they had more airflow, more heat or something, where our ovens were more confined, you know, and so on. It just, there were different processes, different plants, and it was always frustrating.
And we never really...
You could really never get your arms around it. Because we'd run a lot of tests where every part that came out of the presses, as I recall, had a code date on it, which was a shift and date it was made, and I think it might have even had the number. Once in a while, if we really wanted to control parts, we would number the parts.
Sequentially?
Yeah.
1, 2, 3, 4.
Yeah.
Wow.
Well, see, the operators are writing this information on them anyway, shift and day.
Yeah.
So all they had to do, and it wasn't that they, then we'd have maybe 2 or 3 different molds. And I can recall that we would even take maybe 12 parts. Well, no, maybe 50 parts. And 1, 2, 3, put them in 3 different baskets. 1, 2, 3, consecutive, same molder. This to there, that to there, and that to Lansing. And then we would watch them. Watch our parts, because they always went through first, and then we'd send someone to tag this container,
Yeah.
send it to Doraville, send it to Arlington, their container, and send someone down there.
And actually see the real.
Actually see the reels, follow them right through. And
Was they
still,
finding
oh yeah,
things?
oh yeah. Yeah, I don't recall,
It was a piece of nitpicking so much.
well, you couldn't, they would find something you couldn't argue. Now, you could argue maybe not whether or not it's acceptable, whether or not it's gonna give the customer a problem, whether the customer's gonna be concerned
Yeah,
about it or
yeah.
not. Now, that is maybe
Yeah, that's,
argumentative,
yeah,
okay? But you couldn't argue that, yeah, there's a very small pin, about like the end of that lead, that you could see on the part, probably. Or maybe Doraville wouldn't accept that any place, and Arlington would say, well, as long as it's not right up here in the normal vision area, we will accept it in these areas. And I think Lansing took a little more practical approach too, as long as it was something that the customer would probably never see, never have any problem with. It wasn't an appearance item that, because you're always better off not to repair.
just like paint.
Yeah, unless you have to. Boy, don't touch it unless you have to. So anyway, that was pretty much the way the operation ran for quite a few years. Yeah, but again, with our burden rates, and SMC is somewhat labor intensive compared to some of the other processes. So in a labor intensive process, it's difficult to be competitive. Injection molding is usually not a labor intensive. It's capital intensive. So we could usually be more competitive in injection molding, and I don't think you and I want to get into a discussion on the GM accounting methods, but you can play, and I don't mean this direct, you can play their accounting game. As an example, if you take a double cavity mold and put it in a large machine, and you have one operator, I think, let me be sure I'm saying this right, you have a certain standard hours per part, and you have a certain piece price.
Right.
If you take two single cavity molds of the same part and put them in two different machines, convey them to a single operator, you do not have the same piece price. Now, I know that doesn't sound right, and I'm not saying something right, but it is true that our people locked in that we could not be competitive on small machines. So we had to buy 2, 4, even sometimes 8 cavity molds and run them in the big machines. And where again, a lot of our competitors would only buy a single cavity, or maybe 2 or 3 single cavities, depending on the volume, and run them in smaller machines. Now, the thing that I guess one of the things that I guess that our accounting never recognized, maybe this is what I'm alluding to, that any competitor does, that his burden rate for different machines is different. Okay, so ours is not. So in paper, we run a 2,500 ton machine for same cost as a 500 ton. And so on paper, we were always very, very competitive. That was it. That's it. In the big machines, but not in the small machines.
Just carry each other.
Right, right. That was it. So a lot of the red light studies, red, yellow, and green, and so on, county just locked in that we were not competitive in the smaller machines due to our accounting practices.
Yeah.
Now, whether or not we really were, I don't know. It's a problem with our system. So anyway, that is pretty much kept injection molding going, because it shows us in the big machines very, very competitive, because our labor is competitive with the outside people, and our burden rates on that machine are lower than many times the person on the outside. It has a true burden picture of each machine. Now, when you get into SMC, that's what I'm alluding to. There, you're quite labor intensive with big machines with nothing to offset it. And of course, you had a lot of hand work in the paint and the refinish and all that. So it was always an uphill struggle to maintain competitiveness. But I don't know what'll come out of all this, but it seems like at GM, I always felt needed in-house production to keep the outside guy honest.
It's just a methodology
It was,
to
right.
sort apart.
Keep him honest. And also, GM, I think to some extent still is, although probably not as much as they were a few years ago, willing to pour money into development.
Mm-hmm.
Now that I know has gotten hurt a little bit in the last few years. But by keeping in the forefront of development and technology and so on, with your in-house operations, you force the people on the outside to keep modern. And
you keep making these steps.
Right. And they're right there with you. Maybe a step behind, but they're right there with you. Now, without that requirement, you're relying on the outside molding family to keep each other competitive and advancing in technology and so on. And I know like I say, in SMC, when we developed some quite good relations with the outside molders in terms of, I'm surprised when you think back some of the things we tell each other, but you kind of looked at it as a fraternity, so to speak.
Sure.
What helped you helped him, but it helped the industry. And so we've had a lot of very open discussions.
It's not
back
trying to
then,
be secretive.
no, well, some things, occasionally you wouldn't tell them, they wouldn't tell you, but we still had a lot of open discussion, so that it benefited everybody. Now, I don't think the outside molders themselves had these discussions with each other to the extent that we did, because they knew that we weren't going to take certain business from them. We had no desire to. Hopefully they weren't going to take, certain business from us and so on. That
Plus we have some knowledge base.
Right. And so whether or not that'll still prevail, I don't know. Kind of scares me a little bit. Because as I say, Guy Lamp got out of SMC many years ago. And I don't know if Chevrolet is still in it or not. Chevrolet got into it several years after we did. Buick, Pontiac. Buick did. They got into what they call BMC, which is injection molding polyester material. Oh, that makes me think back. One other thing here. Yeah. We bought and had a project. Let's see if I can find it on our list here. Yeah. In 1968, we bought an IMCO machine.
Okay.
And we had a program with IMCO and on the equipment that we were going to try and take liquid polyester, which is the same material that's in SMC, chopped fiberglass in a hopper right over an injection molding machine, run it through a screw into a plunger on the machine, and injection mold that into mold.
So you kind of mix it in the machine.
We're mixing it right as we want. We're mixing it on the fly.
Okay.
So this machine had that capability, but it also had the capability that we could convert it to a straight injection molding machine. It was just a conversion package.
Just in case.
Well, yeah. And so this had never been done. So we started and we bought drums of material, I know, and back, I think Warren, maybe that's why we bought, maybe that's one of the reasons we had Warren, hired Warren. to work on that project too. Warren Diebold, he'd have to tell you that. But anyway, we tried to make fender extensions that way. But
you were doing nylon.
yeah, and we were looking at this too, and using the same molds as I recall, except there you had to heat them.
Oh.
Very hot. Heat them with hot oil. And of course that presented some problems because the molds were not designed to run that hot specifically, but we worked around them. But there again, we could never make the process work. As I recall, the main problems we had were that you could get a fairly good mixture of the glass and the resin going through the screw, and then the screw itself filled the shooting chamber or the plunger. But when that plunger came forward, you're trying to inject this material through a sprue just like you would in an injection mold. So all the glass oriented, right straight in line. And then once it got inside, it seemed like it balled, and the resin just flowed all over. So you kind of had the clumps of glass in one area and the rest was the resin. So we worked on it quite a while with different resins and so on, but it never worked. I don't think to this day anybody's ever done it. But what Buick did come up with a process, or they used it, some other people used it too, is they took, in essence, SMC sheet, the same type material, and made it into a rope.
Okay.
And then this rope they put into an injection molding machine.
So they actually went through the...
Yeah, but they treated it more like SMC, that it did not actually go through a little nozzle like we were putting it through. They just rammed this whole rope, which is maybe inch, 2 inches diameter. I don't know, it's been a while, and they had a charger there that took this rope and just pushed that into a mold. And they actually made front end panels for several years that process. But again, a lot of the same problems as with SMC. Appearance-wise, probably a better looking part, because due to the high pressure and the method of injection, you forced all the air out. You didn't have all these pockets, but you did have the same glass orientation, the problems and so on. Although they reinforced their panel across the top with a pretty heavy metal bracket, as I remember, that they bonded.
So ours was just plopping, they're basically loose.
Right. Yeah, we had the strength built into the panel, whereas they reinforced it. But they used that process for some years. I don't think it's still in use any place, but it could be in a different form, and that's called BMC.
Okay.
And
these stood for what?
Yeah, bulk molders. Ours was sheet, theirs were bulk. There's also a TMC now, which I don't know what the hell that stands for. Okay. It's kind of taken over from that process. But anyway, then came RIM. RIM is reinforced reaction injection molding. And
about when?
Yeah, that's what I'm trying to think. We developed the tech center. Again, we were working very closely with the tech center. Was working on rim fenders. There were some fenders around.
So we made an Omega with a floppy fender.
Right. So we started a program then to make the Sport Omega fender on the 1980 Omega.
I think it was 80.
It was 80. And it had a different profile from the sheet metal. It was painted different. It was white on top, silver gray on the bottom, as I recall, and seemed like it might have even had a decal on it.
I think it did. The Sport Omega was on the side of the car.
Yeah, that was on the door, I think. But so we started to develop this, and we built two molds by two different vendors two different concepts. One was hydraulically actuated molds for the cams and lifters, and the other one was a mechanically actuated mold. There was still uh, differences of opinion which was the best way to go. So and I don't recall anymore which hand was which, but we had two entirely different vendors. One of our vendors I know was a little more in favor of mechanically, and another one liked hydraulics in our injection mold. So these molds were similar to injection mold.
But they didn't use that kind of a machine, did they?
No, completely different machine, but the tooling was somewhat similar. And we then got approval from the corporation for a development project, which we put down on Building 34. Now that project included a rim machine, a complete, we were the first ones also that were going to use glass in rim, reinforce it. Standard rim is RIM, just reinforce, which is your common urethane molding. And, but we wanted to use glass to get the stiffness and so on. Fender, yeah. So we put got approval for the development area, and as I say, we had the machine, we had a complete miniature glass blending system. Okay. We had a wash booth. We had a double oven, one for post cure and one for painting. So with this facility, we could produce a complete part of anything we attempted to. So the rim fender was our first program that we brought in house.
Big part to work with.
It was a big part. Had a lot of potential though. Again, we could give them a different styling at reasonably low tooling cost for a fender. Maybe even do some things that the sheet metal fender could not do in terms of styling. And give them impact resistance. That was one of the things that everybody was after. And one of the tests was simulated, I know, running a grocery cart into the fender. I think Charlie Porter and Product worked quite a bit on the testing, and he developed some kind of unique pendulum impact type tests and so on. The fender was very, very forgiving. Yeah, and in terms of that. So, like all programs, we had a lot of development problems in terms of materials and the glass, never having been done before. Yeah. But we finally did end up getting some cars built at Willow Run, and I think we would build them in batches of maybe 20. And how many we actually put on, I think again we were shooting for 500, again 1980s, but I think we ended up somewheres around 120, 30, okay, somewheres in that magnitude. But again, one of the things that we should have learned from SMC, and we thought we did, but I guess we didn't, was peak lines. That our fender was beautiful. Okay. Matched the model 100%. But the sheet metal fenders didn't match Doodley. Oh, God. So when we started to put these on the cars, that was the first thing that we saw. And another thing that was true of the rim that was let's see, trying to think now, was cross car variation. We were very consistent, although I think that Omega had, I think it had an SMC.
It had a front end panel.
Had a SMC front end panel on it. So we had the front end panel and the fenders very consistent in dimension, whereas the sheet metal,
the hood had been in the hole.
Right. The sheet metal fenders used the same SMC, but they were a little more forgiving. So we ran into problems lining up the peak lines, of course, being so sharp. So I don't recall whether we had to go in and rework the molds or whether we were sanding the parts or what, but you don't like the sand rim, because one thing that is kind of hard to envision, even today, rim is not a solid material, it's a foam. So it's the same as your mattress on your bed.
Oh,
The only
okay.
real difference being that your mattress on your bed might have a 20% density,
Yeah.
and the material we were making was maybe a 98% density. But there, so you actually use that phenomena to pull your molds out. That the material goes in and actually expands in the mold. So in essence, you put in a measured amount of material, a very precise amount, and then you allow it to expand. So what I'm alluding to, you would rather not sand.
Did it have the skin?
Yeah, it would skin.
So if
Against the mold. Yeah, you could. You never knew what you were going to get into.
Yeah.
So again, that gave us
34?
yeah. Yeah, for the original rim fenders. At the same time, then we were selling the program to Pontiac for the Fiero,
Okay, yeah.
and I believe we actually ran the original Fiero doors, fenders, and so on in 34.
Oh, did you?
Yeah, I think we did. It was a pilot, but the equipment was full size. I mean, it wasn't, except for the glass blending.
Yeah.
We couldn't blend huge amounts of material, but we could blend enough to keep the area going and so on. Had very good controls on it. So I guess that area's been ripped out. I'm not even sure if it's still there.
Then it all ended up eventually out in.
I think they did it.
Yeah.
Well, they probably
making room out there.
Well, yeah, but the pilot area still stayed.
What do you think the pilot area stayed
for a long time? It stayed in. It was still there when I left.
Okay.
And there were a couple of men assigned to that area, hourly men, that would run the equipment. And although they eventually, I know they were using more and more out in the main area as the development programs. But the theory behind that was we were to bring in all the new molds and everything and try them out, debug them there. Well, part of the problem, and I'm not again sure what happened, the machine that we had in there turned out to be too small. It was called a Rim 90, which I think meant it had 90 tons of clamp and a certain bed size. And although there were some Rim 90s out in the area in 78, the newer machines were all 120s, I think. 125s, yeah. And they had a bigger bed for the Corvette fascias and so on. Now there was some talk, and again, if they were going to take that Rim 90 out of 34 and put in a 125, I don't know if they ever did or not, so that they could again go back and try out the bigger molds, or maybe it was more efficient to try the bigger molds out in the production area. But
how did we end up? How come Pontiac did do this thing for their car?
It was an expensive process to get into, and we kind of had the certainly most of the technology on glass reinforced. We had to bid on the Pontiac against the outside people. They didn't. Oh yeah, they didn't give it to us. And there was always some problems and that type of program dealing with another division, but I think we did basically all right for them. I know there were times we sent parts down to them in taxi cabs.
Because we were a little tight.
We were a little tight, and but we had that job. We had the Corvette. We originally, I think the first part that we started on was our own J car fascia. Oh, the Forenza.
Yeah, the floppy bumper.
Yeah, and right now I can't even vision that part, but it doesn't matter. So that was the first one we got into really production with that part. So we were in production with that at the time. I think we were trying to sell the program to Pontiac, or maybe they had awarded it to us, but we were equipping it. And
what had how had we evolved into that kind of part, the soft part?
Well, kind of, I guess the handwriting on the wall that you could see some SMC parts going into rim.
Okay,
You know, they were getting rid of bright bars and
all right. So this was kind
and
of part of
yeah,
that evolution.
yeah. Now I can envision that part. See that originally at J Car Part Forenza included all around the headlamps. I think the bumper,
Yeah, I remember the bumper.
the valence. It was a reasonably good sized part. It was the whole front end of the car. Is what it was. And of course, that would have knocked us out of a lot of the front end business. And the 88s and 98s, the rim part was just a rather small part right in the bumper area.
Okay.
The rest stayed whatever it was. And then the Corvette, of course, they were changing to rim. So
Right.
we got that business. I'm not just sure. Gordy Crater gave you a lot of history on it. We kind of went after it, but then we kind of didn't want it.
Oh, really?
Yeah. And they pretty much forced us
That's unusual.
to take it because they liked what we were doing. But it was a very tough part to make. And I think is what happened. We probably had underquoted it a little bit due to our lack of knowing what the true costs were on these big parts at that time. I know we had a lot of financial problem with Pontiac not wanting to pay the price for the parts that they would keep change. For instance, I know I went over there one day to a meeting. I guess, sorry, put this on tape. And the original drawings that we had quoted, the fenders, doors, quarter panels, had no tolerance on them whatsoever. No tolerance on the drawings.
Plus or minus a mile.
Nothing. So in the meantime, they had come through with engineering changes, numerous changes, and tolerancing and so on. So we recognized that we were underbid, that to hold closer tolerances was going to be a little more expensive. So we were learning about the process too. So we wanted to up the piece price and wanted them to pay for engineering changes and what I found out, I guess I had known because we had been involved in the Fiero program. See, the Fiero was not designed at Pontiac; it was designed by Intech.
Oh, really?
Yeah, designed off premises. And in talking to the Fiero people assigned to Intech, we got pretty good information on the programs and so on. But it turned out that Fiero, in my opinion, was grossly underfunded. So they couldn't admit it, but their hands were tied. So being an allied division, they were holding our feet right to the fire and not giving it. In fact, they wouldn't pay anything for tolerance changes. They didn't even want to pay for the tool changes and so on. And but there was a lot of interesting work done. I know one of the things, we were the first people to try and bond rim to rim. Two pieces, yeah. Rim to sheet metal had been done before, but rim to rim. So we bought some robots because the only way you could bond rim to rim was to use a two-component urethane adhesive, because rim itself is an adhesive, urethane itself is an adhesive. And so we bought these robots, and they had to put a very accurate bead of material all around this door frame to bond in the reinforcements. And not only that, but because you were bringing two components together, you had a little static mixer about the size of a large soda straw, which was a small cousin to the static mixer we used in the SMC room. Well, after every cycle of bonding, you had to purge all that material out or it would set up. And so that was a constant problem to get it.
Well, you were changing soda straw.
Yeah, and they were expensive. I think they were, I don't know. And there was no good way to clean them once that urethane, because there were a whole series of little flights in there that cut this material. Right. Well, they went all the way across. They just, so, and then we had adhesion problems. So we bought a machine to try and blast the surfaces with the walnut shells or something, rough it up. You see, rim, when it comes out of the mold, valve has a mold release on it. Now, if you use a water-soluble mold release, in theory, I think your washer takes it off. But we ran into some problems with water-soluble mold release. So if you try and use a wax-based mold release, the washer doesn't want to take it off, but you can get the parts out of the mold. I don't know. You have to talk to some other people. I'm really hazy on some of these details. But anyway, we ran into bonding problems, and we really never knew if we had a good bond on the door or not, because we bonded and all. It was a destructive test.
You had to pull it apart.
Had to pull it apart. So we pulled a lot of them apart. And of course shipped a lot of them, and to my knowledge, I have never heard of any Fiero doors having a feel problem. Now Pontiac found some in the plant that when they would assemble,
Put some stress on it.
They might pull the bond. But I know we were even buying Windex in 55-gallon drums. Someone came up with the idea. We were trying everything that and we set up a wash booth. That Windex would remove this mold release, because we really never got the blaster going. It was to be an automatic machine, and it just never worked. Right. Well, I say it was nuts, but I think it was a plastic bead. But Gordy Crater was pretty much instrumental in designing a one-piece door. So I think before the Fiero was maybe a year old, we got the one-piece door approved from Pontiac. Solved the problem. Unfortunately, it was not interchangeable with the original one. So this was going to present a real problem for service. But I think we did buy or I guess we had, when we first got into the business, we had built some hand bonding fixtures because they had to be heated. And so we retained those for service, and I think eventually Pontiac gave us the okay. I think I left the Remery about that time to give them so many sets for lifetime. Because they could have used the other door, but I think it took a different reinforcement, and they didn't think the customer would pay for it. I think they found out that there was very little service on that part anyway. That if you damaged it that bad, you had to replace the whole door and reinforcement and all that. You couldn't just get away with the skin. So of course, they made the Fiero door until Fiero went out of business. They made the Corvette, both the front and the rear fascias. We got into the Olds 88 and 98. I don't know if we called it a fascia or not. It was essentially just around the bumper. But I think we ended up with some Buick. I'm almost sure we ended up with some Buick parts too.
Were we the only guys in the corp doing it?
No, Guide was.
Guide was doing it.
Yeah. And we worked very close. Guide in some ways had a better system than we did. Some ways we had a better system. They had quite a nice bulk material handling system that we didn't get into for a while. But Guide was not using reinforced rim. See, that's why we had kind of. Now I think eventually they got into it. So, but I'm not sure whether we gave them the technology and so on. We had a corporate rim task force that I was on. We met. It seemed like we met once a week for a year or so. That Guide was on it. I think Buick, although I'm not sure, GM truck. And we would always kind of divvy the pie up in this meeting. Yeah, GM of Canada had a rim plant. They came on stream after we. So we'd each quote the parts out, kind of sit down there and haggle and so on. But it kind of kept the this activity out of the high levels of the corp, because whenever it went to the corp, it was kind of a unified thing that Olds was going to do this and Guide would do this, Canada would do this, and
all agreed down.
we had people on that group that would analyze all the shipping costs and labor costs. And of course, Canada always had the lowest labor costs because of their health insurance. Their burden rates were lower and so on. Electricity, I'm surprised, is lower, Canada. Yeah, due to, well, some other subsidies, I guess, on it. And Olds and Guy, I think we were always a little under guide. Shipping costs are quite an item on RIM because they're big parts, light parts,
Sure.
ship a long way. So we always had an advantage on any in-house parts, as well as any part that maybe was used in Lansing as well as someplace else. Whereas Guide would have an advantage on, you know, some other parts. Right. But it was always kind of an interesting situation. In fact, it took a day and a half whenever we met. Maybe we only met once. I think there for a while it was every 2 weeks. Could have been even every week because I didn't usually stay down at night, but the other guys did. We'd have an afternoon meeting, and then they'd stay down. And well, I guess we'd meet. Maybe we'd meet all one day. Yeah, they'd come in the night before. We'd meet all one day, and then if we needed to, the next morning. Well, sometimes I didn't always go to the morning, but I very seldom stayed down. But again, you got to know the people pretty well. And
did you transfer technology, or was it basically a part?
It was basically part at that time, but later on we started to transfer some technology, and we'd go to their plants, they'd come to ours, and so I'm not sure if Guide is still in the room business or not. There's a question whether or not they're going to get shut down. The last time I talked on this latest,
This current schmoz?
yeah. So anyway, that kind of brings us up to date, Jim, on what I know, and there's people over there that can, you know, really bring you up to date on RIM.
It's still continuing.
Yeah, continue on. Ray can certainly give you SMC, and Gordy can cross a lot of. He was involved in both RIM and SMC in the early part of it. So it'd probably be a good idea if you want to get a little more area.
See, when did you say you retired, Larry?
April of '88. Yeah, just about 4 years ago. And like I say, any of this stuff.
I'd like to borrow your pile if you don't mind.
Sure. And, run through it.
We'll reproduce it.
Yeah.
What we would like out of it, and then I'll mail it back to you.
So just give me a call. I'll come up because I told Ray I'd get it back to him.
All right. I can get it to Ray.
I didn't bring it all over.
Oh. Okay.
Yeah, I got half of it. I just brought the stuff over that might be the refreshers. Okay.